the roots of the quadratic equation x squared minus x plus 2 equals to 0 are alpha and beta. Prove that 1 over 1 plus alpha squared plus 1 over 1 plus beta squared is equals to negative half. The quadratic equation is x squared minus x plus 2 equals to 0. They said the roots are alpha and beta. Generally, if a quadratic equation is in the form ax squared plus bx plus c equals to 0 and the roots are alpha and beta, then the sum of roots alpha plus beta is equals to negative b all over a, and the product of roots alpha times beta is equals to c all over a. B here is the coefficient of x, a here is the coefficient of x squared, and c here is the constant term. You know that x squared means 1x squared and x means 1x, so the coefficient of x here is minus 1. Comparing this quadratic equation with this one, a here will be equals to 1 and the b here will be equals to negative 1. C will be equals to 2. Alpha plus beta, which is the sum of root, is equals to negative b all over a. That is from this formula. In the place of b, I'll put negative 1, and in the place of a, I'll put 1. That is negative times negative 1 all over 1. You know, negative means positive, so it means that here I will have 1 on 1, which is equals to 1. So alpha plus beta is equals to 1. The next is to calculate alpha times beta. Alpha times beta is equals to c all over a. That is from this formula. C is 2. So it means that here I'll have 2. A is 1, which is equals to 2 all over 1 is 2. It means that alpha times beta is 2. Let me say this is the left hand side of this equation and this is the right hand side. I want to show that the left hand side is equals to the right hand side. So I'll start from the left hand side. The left hand side of this equation is equals to 1 all over 1 plus alpha squared plus 1 all over 1 plus beta squared. The LCM is the product of the denominator of this fraction and the denominator of this other fraction. 1 plus alpha squared times 1 plus beta squared. 1 plus alpha squared will divide this by 1 plus beta squared. That's 1 plus alpha squared. We cancel this and I'll be left with 1 plus beta squared. 1 plus beta squared times 1 is the same as 1 plus beta squared. Now 1 plus beta squared will cancel out here and I will be left with 1 plus alpha squared. 1 plus alpha squared times 1 is plus 1 plus alpha squared. That means this is equals to 1 plus 1 is 2 and then plus alpha squared plus beta squared all over 1 plus alpha squared times 1 plus beta squared. Recall that the expression alpha squared plus beta squared can be written as alpha plus beta, all that squared minus 2 alpha beta. Now let me multiply this expression out. That is 1 plus alpha squared times 1 plus beta squared is equals to 1 times 1 plus beta squared plus alpha squared times 1 plus beta squared. That's, I take this one, multiply this bracket plus this alpha squared times this bracket. Now 1 times 1 is 1. 1 times beta squared is plus beta squared plus alpha squared times 1 is alpha squared. Alpha squared times beta squared is the same like alpha squared beta squared. Now you see that this will be the same like 1 plus alpha squared plus beta squared plus alpha squared beta squared. You know that alpha squared beta squared is equals to alpha beta, all that squared. I will need to substitute these two equations in this expression and this one. That means the left hand side of the equation will be equals to 2 plus alpha squared plus beta squared. You know, alpha squared plus beta squared is equals to this. That is 2 plus alpha plus beta all the squared minus 2 alpha beta all over this expression, which I expanded to this 1 plus alpha squared plus beta squared, which is this from this formula. That is alpha plus beta all that squared minus 2 alpha beta plus alpha squared beta squared. And you know, alpha squared beta squared is equals to alpha beta squared. So it means I will replace alpha squared beta squared here by alpha beta squared. That is plus alpha beta all that squared. Now you see that I've put this expression in terms of alpha plus beta and alpha beta. I can then substitute 1 in the place of alpha plus beta and 2 in the place of alpha beta. That is 2 plus 1 squared, that's alpha plus beta is squared, so I'll have 1 all the squared minus 2 into alpha beta, which is 2. So here I have 2 all over 1 plus alpha plus beta squared. That is 1 plus 1 all that squared minus 2 into alpha beta, which is 2. That is here is 2 plus 2 all that squared, since alpha beta is 2. I need to simplify this expression. Now this is the same like 2 plus 1 square. 1 square is 1 minus 2 times 2, which is 4 all over 1 plus 1 square, which is 1 minus 2 times 2, that is minus 4, plus 2 squared. 2 squared is 2 times 2, which is 4, that is plus 4. Now here at the numerator I'll have 2 plus 1 is 3, so I'll have 3 minus 4. 3 minus 4 all over 1 plus 1 is 2. Minus 4 plus 4 is 0. So I'll have 2 plus 0. Now 3 minus 4 is minus 1. 2 plus 0 is 2. And you see, this is negative half, which is equals to the right hand side of this equation as we are required to prove. So here the proof ends.